Hello again. This lesson is about scalars and vectors and the terminology that we use in physics when we're talking about those things. So, for starters, a number is a scalar if it doesn't have any direction to it. If it's an amount without a direction. If we say that a square has four sides, or that a carbon atom has, not four, six protons, or what else would be a scalar? If we say that this lesson will be 10 minutes long, that's not a promise, I just made that number up. Those numbers are scalars because they don't really have any kind of orientation to them. A number is a vector if it has an amount and a direction. Or sometimes they say a magnitude and a direction. So if you look at a bank statement, most of mine have a plus every couple of weeks when I get paid, and then a whole bunch of minuses after those. The pluses mean that my balance is going up, and the negatives mean my balance is going down. So you could think of that as a vector measurement. If you're moving, sometimes we measure your velocity, and we'll say that it's positive if you're going forwards or it's negative if you're going backwards. If you're flying a plane and there's an altitude change, we can use, so for height, we might say that gaining altitude is a positive and losing altitude is a negative, things like that. So let's see how that looks when it comes to our physics concepts. Some examples of this would be, let's talk about a hike just to get ourselves started. Imagine if you start at some point when you're out on a walk and you go 3 kilometers this way, east, and then you go 4 kilometers north, and then you go 3 kilometers west, and then you go 4 kilometers south. We could give you something like this and say, how far did you go? And there are actually two answers depending on whether you think of these amounts as scalars or as vectors. The two questions, or the two answers, if we ask how far, go like this. One of the things that we could do is count all the ground you covered. Ground covered. If you're talking about how tired you are or how sore your feet are, you might say, I went 3 kilometers plus another 4, plus another 3, plus another 4. That's a total of 14. 3 plus 4 plus 3 plus 4 makes 14 kilometers. When I did that, I didn't pay any attention to what the directions of any of these movements were. I just counted them all as positive numbers and totaled them up. When you do that, that is called a distance, and it gets the symbol D. When we do that, we're saying we're ignoring direction. And because there's no direction on this, what I just did is called a scalar addition. I didn't pay any attention to the directions. We said that scalars are numbers that don't have any direction. So the distance for this would be 14 kilometers. Another way that we could have counted this, as you saw when we talked about vector components, is I could say in the x direction, see I'm using the word direction already the instant I start doing this, I have a positive 3 from when we went east, and then I have a negative 3 from when we went west, total of 0. In the y direction, I have a positive 4 from when we went north, and then a negative 4 from when we went south, total of 0 again. If you're doing that where you're counting the direction, if you're counting direction, then what you are finding is a displacement. And the symbol for that is a D with a little arrow on it. The displacement here is 0. So the distance is saying, okay, you covered 14 kilometers of ground, good workout. The displacement is saying, well, you started at this point and you ended up at the exact same point, so you are 0 meters away from your starting point. Waste of time if you think of it as trying to get from A to B. So we have these two measurements that can tell us different things. Distance is how far did you travel, or how much distance did you add to your odometer, how tired are you, how much fuel did you burn. For that you probably want distance because you don't care about direction. If you do care about direction and you want to know how much did all this moving actually accomplish, then you want a displacement. Now, full disclosure, people are not great about remembering to put these arrow symbols on. So sometimes you will see D equals 0, and what that would mean is that somebody neglected to put the arrow symbol, but they should have. And if you give a direction, then you don't put the arrow symbol, you just say D equals 14 kilometers. So try to be good about this and put your arrows. I will too when I'm doing vector problems, but if you don't see that symbol, just be aware that it's something people sometimes forget to do. Hopefully they put the word displacement somewhere in there. If they don't, be forgiving, you'll forget too from time to time. So, coming up with a list here, scalar and vector. The scalar measurement for how far is the letter D, and we say that that stands for distance. If you're measuring how far with vectors, then you have D arrow, and we call that a displacement. And the other big one that will come up is for how fast. A simple V gets the name speed, and that doesn't count direction. And oops, sorry, I looked at the D and then I drew another D. The vector version of that is V with an arrow, which we call velocity. Now the formulae for these are only different in whether they're scalar or vector. So you have the formula D equals VT. This, because it doesn't have any arrows on it, is the scalar version. It says the distance you covered equals your speed multiplied by time. If you put vector arrows on it, you get displacement equals velocity multiplied by time. So if you're trying to find a displacement, make sure you're using velocities. If you're trying to find a distance, make sure you're only using speeds. This doesn't come up a tremendous amount, but if you see these symbols, I want you to know what they mean, because every so often they'll make a difference to how you do your calculations, to whether you pay attention to direction or whether you do not.